When we look up at the night sky, we see a universe teeming with stars and galaxies, each one a distant sun with its own mysteries. It's easy to feel small, gazing into the vastness and to wonder about our own place in this cosmic ocean. Yet, our solar system is just a tiny part of this immense expanse, a single family of planets orbiting an ordinary star, surrounded by countless others. We usually picture the solar system as the sun and its 8 planets, stretching from Mercury to Neptune, each world unique and fascinating in its own right. But where does it actually end? Is there a final border, a line that separates our solar system from the rest of the galaxy? The truth is, the solar system doesn't have a hard edge. It gradually fades into interstellar space, blurring the boundary between what is ours and what lies beyond. Beyond Neptune lies the Kuiper Belt, a vast ring of icy debris and dwarf planets like Pluto, Eris, and Haumea. But even this distant region isn't the true end. Farther still, the sun's gravity weakly holds on to a distant, mysterious realm, the Oort Cloud, a place so remote that it's never been directly observed. The Oort Cloud is a theoretical, spherical shell of trillions of icy objects, enveloping the sun and planets like a ghostly halo. It's thought to be the birthplace of many long-period comets that occasionally visit the inner solar system. It's so distant that sunlight takes over a year to reach its inner edge, and nearly 3 years to reach the outermost parts, so far that the sun is barely more than a pinpoint of light. Here, the sun is just another bright star among billions, and its gravitational grip is barely felt, almost lost to the pull of the galaxy. The Oort Cloud marks the true frontier of our solar system, a place of profound cold and darkness, where the sun's influence finally gives way to the galaxy beyond, and interstellar space truly begins. This is not just the edge of our home, but a boundary between our solar system and the rest of the Milky Way, a threshold few human-made objects have ever crossed. Exploring this distant realm is one of astronomy's greatest challenges, pushing the limits of our technology and imagination as we seek to understand where our solar neighborhood truly ends and the galaxy begins. Imagine a colossal hollow sphere of ice and rock, with our solar system at its center. That's the Oort Cloud. It's an invisible boundary, far beyond the planets we know, marking the edge of our sun's influence. If you could travel outwards from the sun, past Neptune and Pluto, you'd eventually reach this mysterious, distant shell. Proposed by Dutch astronomer John Oort in 1950, the Oort Cloud explains why some comets appear from all directions, not just along the flat plane where the planets orbit. These comets seem to come from the farthest reaches of our solar system, hinting at a vast, unseen reservoir. The Oort Cloud is made of trillions of icy planetesimals, ancient leftovers from the solar system's formation, scattered outward by the gravity of giant planets billions of years ago. These cosmic snowballs are frozen mixtures of water, methane, ammonia, and other ices, preserved in the deep cold for billions of years. Each one is a time capsule from the dawn of our solar system. Despite its vast population, the Oort Cloud is incredibly sparse. Objects are separated by millions, sometimes even billions of kilometers. The distances between these icy bodies are so great that they would rarely, if ever, collide. Its total mass may be several times that of Earth, but it's spread across an almost unimaginable volume, forming a shell that may extend nearly a quarter of the way to the nearest star. The Oort Cloud has 2 parts, a thick, inner disk called the Hills Cloud, where objects are more densely packed, and a vast, spherical outer region that forms a shell around the entire solar system, stretching almost halfway to other stars. The outer Oort Cloud is only loosely bound to the sun, and can be easily disturbed by the gravity of passing stars, or even the tidal forces of the Milky Way itself. Occasionally, these disturbances send icy bodies hurtling toward the inner solar system, where we see them as long-period comets with orbits that can last thousands or even millions of years. The Oort Cloud is a cosmic deep freeze, preserving the building blocks of our solar system, and holding secrets about its earliest days, waiting to be discovered. The Oort Cloud's scale is almost beyond comprehension. It is a vast spherical shell of icy objects that surrounds our solar system. Earth orbits the sun at 1 astronomical unit, AU. That's about 93 million miles or 150 million kilometers. Neptune, the farthest planet in our solar system, is 30 AU away. Voyager 1, our farthest spacecraft, is over 160 AU from the sun, barely a step toward the Oort Cloud. It has been traveling for over 40 years to reach this point. The Oort Cloud's inner edge starts around 2000 AU, stretching out to as far as 100,000 or even 200,000 AU. This makes it an incredibly vast region. That's up to 3 light-years away, nearly halfway to the nearest star, Proxima Centauri, which is about 4.21 Kuiper Belt, Detenia Horbonkwanen, Otskor Dan Stwervaden, Sun. If the Sun were a marble, the Oort Cloud would begin 2 kilometers away and extend for 100 kilometers. This analogy helps us grasp its immense scale. Our entire planetary system is just a speck at its center, surrounded by this enormous cloud of icy bodies. The Oort Cloud is a vast dark wilderness where the Sun is just a bright point and temperatures hover just above absolute zero. It is a region of extreme cold and darkness. Objects here move slowly, taking millions of years to orbit the Sun. Their orbits are influenced by the gravitational pull of passing stars and the Milky Way itself. This immense invisible sphere defines the true boundary of our solar system. It marks the edge of the Sun's gravitational influence. Beyond it, the Sun's gravity fades, and interstellar space begins. This is where the influence of other stars and the galaxy itself becomes more significant. The Oort Cloud is the solar system's final frontier, a mysterious and largely unexplored region that holds many secrets about the early solar system. No one has ever seen the Oort Cloud directly. It's too distant, dark, and diffuse, so how do we know it exists? The answer lies in the comets it sends our way. Long-period comets, which take thousands or even millions of years to orbit the Sun, arrive from all directions, not just the solar system's plane. This random distribution suggests a vast spherical reservoir of icy bodies surrounds us. John Oort pieced together this evidence in 1950, tracing comet paths back to a distant, unseen source. The composition of these comets, pristine ices untouched by the Sun, confirms they've spent eons in deep freeze. Computer models show that as the giant planets formed, their gravity flung countless icy bodies into distant orbits, creating the Oort Cloud. Every long-period comet is a messenger from this remote region. The Oort Cloud's existence is inferred from the clues left by these icy wanderers. It's a triumph of cosmic detective work. The Oort Cloud is the solar system's comet nursery. Here, frozen comets drift undisturbed for billions of years, until a passing star or the Milky Way's gravity gives them a nudge. These gentle tugs can send a comet plunging toward the Sun on a journey that takes millions of years. As it nears the Sun, the comet's ices vaporize, forming a glowing coma and spectacular tails. Some comets, like Hale-Bopp, become brilliant visitors in our skies before returning to the darkness for millennia. Occasionally, a comet's orbit is altered by the giant planets, trapping it in the inner solar system or ejecting it into interstellar space. The Oort Cloud is a dynamic reservoir, slowly replenishing the supply of comets that light up our skies. Each comet's journey is a cosmic odyssey, shaped by the gravity of stars and planets. These icy wanderers are both beautiful and scientifically invaluable. The Oort Cloud is a living link between our solar system and the galaxy beyond. The Oort Cloud is a time capsule from the birth of our solar system. Its objects are pristine relics, frozen leftovers from the Sun's formation 4.6 billion years ago. While most debris was swept up or destroyed, some was flung far from the Sun by the gravity of giant planets, forming the Oort Cloud. Preserved in deep freeze, these bodies are unchanged snapshots of the early solar nebula. When a comet from the Oort Cloud approaches the Sun, its gases reveal the chemical makeup of our solar system's origins. By analyzing cometary material, scientists learn about the molecules and conditions that existed when Earth was forming. Comets may have delivered water and organic molecules to our young planet, seeding the ingredients for life. Each Oort Cloud comet is a piece of the puzzle, helping us reconstruct our cosmic history. Studying these ancient visitors lets us peer back to the dawn of the solar system. The Oort Cloud holds the secrets of where we, and our world, came from. The Oort Cloud's vastness hides more than just comets. Some scientists speculate it could contain dwarf planets or even a massive unseen world, Planet 9, whose gravity shapes distant orbits. If such a planet exists, it would be a true giant, orbiting far beyond Neptune and taking thousands of years to circle the Sun. The Oort Cloud might also hold interstellar objects, captured as our Sun passed near other stars. Some of its residents could be visitors from other solar systems, offering a glimpse of material from across the galaxy. The Oort Cloud is a frontier of cosmic mysteries, waiting to be explored. Reaching the Oort Cloud is one of humanity's greatest challenges. Voyager 1, our most distant probe, would take centuries just to reach its inner edge. Future missions will need revolutionary propulsion, solar sails, nuclear engines, or electric drives to make the journey. A probe could reveal the Oort Cloud's true nature, counting objects, measuring their composition, and perhaps even flying by a primordial comet. While a dedicated mission is decades away, new observatories like the Vera Rubin Observatory will soon discover thousands of distant objects, refining our understanding. Each discovery brings us closer to unlocking the Oort Cloud's secrets. The journey has already begun, in our minds and in our science. The Oort Cloud may seem remote, but it's deeply connected to our story. Comets from this icy realm may have delivered water and organic molecules, helping spark life on Earth. The Oort Cloud records the gravitational history of our solar system's journey through the galaxy. Studying it reveals clues about dark matter, the Milky Way, and the origins of our solar system. It's the final, grand piece of our cosmic home, a silent witness to 4.6 billion years of history. As we develop new tools and ideas, the Oort Cloud remains one of our most profound frontiers. It's the frozen attic of our solar system, waiting for future generations to explore. The Oort Cloud reminds us how much there is still to discover, right at the edge of home.